just bought this great new 4-processor, 486 box, great fault tolerant support on the drive. Which version of Windows should we buy, Microsoft? Is it 3.1 or 3.0? I'd have to stop and say, Windows doesn't really do a very good job today of supporting that kind of high-end usage, high-end hardware. And so about 3.5 years ago, we began work on essentially a new implementation of Windows. We call that our Windows NT for Windows New Technology. I'll take some of the wind out of Bill Joy's sails from his speech. He'll say Windows not there. Yeah, it's true. It's not there and won't be there till the end of the year. But Windows NT is an implementation of Windows. It's a self-contained operating system. It does not sit on MS-DOS. It contains its own file system, its own memory management. It requires its own networking, if you will. So it's a self-contained operating system that has the Windows user interface and runs Windows applications, both 16-bit applications and a new class of 32-bit applications, which you can run either on Windows for MS-DOS or Windows NT. So Windows NT doesn't replace Windows for MS-DOS. I think Windows for MS-DOS will continue to be the high-volume implementation of Windows. Rather, Windows NT is a high-end complement for high-end hardware, let's call it workstation or server type of hardware, where people really want these high-end characteristics. What I try to do here is give you a little bit of a sense of some of the features of Windows NT. The positioning is probably best put simply. Today, we feel like people have to choose. Either you get an operating system like Unix, which delivers high-end capabilities, or you get the simplicity and Windows base of applications. Windows NT is really designed to provide a single operating system that delivers on the high-end characteristics, that is portable, that'll run on non-Intel processors, that's fully 32-bit, that's built on a preemptive multitasking kernel, that has built-in support for networking, distributed computing features, that's fault tolerant, etc. So you want an operating system that delivers all those characteristics, but still runs Windows applications and has the Windows user interface. So Windows NT is an important product for us on the high end, but it will not be the highest volume implementation of Windows for some number of years to come. Now I'm going to switch and we're going to do a short demonstration here for you of Windows NT. Brad Struss from our evangelism group has joined me. Before we do the demo, I want to highlight that we are working closely with Novell to ensure that we have great support for Windows NT on NetWare networks. Whether you want to run Windows NT as a client on a NetWare network, whether you want to run Windows NT as an application server on a NetWare network, we have delivered parts of the Windows NT source code, frankly, to Novell to really help them get the support for NetWare done very, very quickly for Windows NT. So we're excited by the cooperation with Novell on Windows NT, and we hope that we can deliver a great solution for NetWare users on day one of Windows NT. Unless you had some success? No? Okay, well let me continue for a second, and then we'll come back. Perhaps one of the perspectives, let me ask another question before I spend much time here. How many people in the audience are OS2 users? And how many people have the OS2.2 beta? That's a larger number than the first number. Okay. Let me give you a little bit of perspective then on our different implementation of Windows and OS2, just to give you a perspective. Certainly, a lot has changed over the course of the last 2 years. Microsoft has a strategy of supporting OS2 as a server platform. Our strategy for OS2 on the desktop has obviously evolved. But it might be helpful just to put NT into perspective, to take a look at Windows 3.1, OS2.2, and Windows NT. What I show you on this chart is on a bunch of, shall we say, internal characteristics of the operating system. I characterize the three systems. And I think what becomes apparent to you is that OS 2.2 and Windows 3.1 are perhaps closer in functionality in many ways than OS 2.2 and Windows NT. OS 2.2 and Windows 3 are both systems which are not fully secure, which are not fully robust. OS 2 has memory protection. Windows doesn't have memory protection. They both have parameter validation. Now I'm really off. Okay, there we go. So there's a set of features, but I'd say technically neither OS 2.2 nor Windows 3 is fully 32-bit. So if you look at a technical scale, Windows NT is really the high-end operating system that we set out to build originally, if you will, with IBM. It was a project we were working on together before we had our drift apart. So Windows NT is really designed to target that very high-end space. And Windows 3 and OS 2.2, I think, will both compete in a certain sense for desktop users. I have my own particular view of the competition, but we need not go into that here. From a user standpoint, the good news is Windows NT, as I said, has all of the characteristics of Windows 3 on the desktop. It has the Windows 3 programmatic model, so it runs Windows 3 applications. It has the Windows 3 user interface. It has the Windows 3 application integration characteristics. OS 2 has a few of those features and misses many of those other features. IBM will announce and make OS 2.2 available, I guess, in the next week or so with some level of Windows 3 compatibility. We've done our own preliminary tests on the beta. I encourage you to do your tests if you're serious and interested in OS 2 as an operating system. Going forward, in addition to building the Windows NT implementation, we also see Microsoft Windows evolving as an architecture. And so let me talk to you about the kinds of things that we see adding into a Windows 4, a Windows 5, a Windows 6. To deliver on the promise of information at your fingertips will actually involve delivering a lot of pieces as part of Windows. Not only do we need the operating system, the user interface that we have today, we have some application integration facilities in Windows today that let you really let applications cooperate. We don't have really any none to speak of workgroup computing features built into Windows. Sure, you can attach to a server over the network from within the Windows environment, but we don't really have support for access to remote data, mail, sharing of applications, application integration across the network. So there's a number of workgroup features that we see as important to add into Windows. We have to make it more easy to administer and manage Windows systems on a network. For those of you here in the audience, that's probably self-evident, but the more we can do to provide diagnostics, management information directly from within Windows that you can get at with your favorite management tools, the better off everybody will be. Windows needs to evolve as a base for information access and storage. Today's fat file system, in which we only have these 8.3 character names, we don't have rich query. We only allow you to address or to access files by name, not by their properties, not by their content. That needs to change. And we're actually working on two things that I think are interesting there. Probably the most important is this thing we're doing called the object filing system, in which we try to evolve the file system to include certain database-like capabilities. We try to include content indexing as we go forward. So instead of just saying, show me all the files that have a .exe extension, you can say, show me all the files that were created by Brad. Show me all the files that contain references to meetings with Novell. Show me all the files that contain charts in which sales are greater than budget. Those are capabilities that need to be built into the operating system and which we're working on, if you will, in a longer term sense. The other thing which we must have in Windows, and which I'm going to spend some time on, is we must have an architecture that allows Windows systems to talk to non-Windows systems very easily. This picture, what I do is give you some of the acronyms that we use to refer to some of the things we're doing in these areas. OLE is object linking and embedding. Dynamic data exchange, those are techniques for application integration. MAPI refers to the mail API work that we're doing to build messaging and directory access directly into Windows. I talked about the object filing system. ODBC refers to the open database connectivity architecture, which we'll build into Windows, that allows Windows applications to access SQL Server, Oracle SQL, DBase files, or database files of any form transparently through what we call a Windows Open Services architecture driver. And I'll spend some time talking to you about this concept of what we refer to as the Windows Open Services architecture. The entire Windows design over the course of the last year, we've evolved in terms of the way we go about getting feedback from software vendors to what we call the open process. What we're trying to do is we add new features to Windows, whether they're in the user interface, they're in the workgroup computing area, they're in the administration area, is to put together preliminary views of what we see adding to Windows, sharing those preliminary views with key software vendors with an interest, conducting meetings that we hold generally in Redmond, Washington, where our headquarters are, and then inviting software vendors to comment, critique, and give input so that new features that come into Windows show not only the best thinking of Microsoft, but the best thinking of Lotus, of Borland, of WordPerfect, of Novell, of software publishing, of Oracle. We've done a number of these software design previews through the open process already. We did one on object linking and embedding. We're trying to evolve that specification to be richer and more capable. We did such a briefing on our mail API. We did such a briefing on the open database connectivity work, both of which I think will be interesting to people in this room who care very much about Windows on networks. And there are more coming in the multimedia area, the workgroup computing area, the application integration area, etc. Now, I've referred to this Windows Open Services architecture. Let me talk about what we're doing there, because it too is being subjected to the same open process that we're using for the rest of Windows. It became clear to us, really, I'd say a year and a half or 2 years ago, that it wasn't enough to just say Windows has to work with everything else. To just say, let's go have a great relationship with Novell, let's have a great relationship with DEC, let's have a great relationship with IBM for their host systems, let's have a great relationship with OSF. But we needed to actually take a formal view, have a formal architecture with defined interfaces that allows Windows systems, whether they're being used as clients or application servers, to interact with an array of services on non-Windows systems. I show you here on the chart some of the most important ones: DEC systems, Unix systems, IBM host systems, Novell systems. And whether we're talking about database access or mail or software licensing, it's very important that these things work not only from one Windows machine to another, but through the same programmatic interface, we want to let applications work to these non-Windows systems. So we have developed a formal architecture, which we've chatted about with a number of software vendors through the open process, and which we're now extending to create a broad range of services. We call this the Service Provider Interface Architecture in Windows. And this picture portrays it probably as well as any. As we start to add more and more network or distributed type features to Windows, we'll not only define an API for software programs to talk to Windows that can talk to other Windows systems, but we will also, below the API, define what we call an SPI, or Service Provider Interface, which is kind of like a device driver interface, except it talks to a foreign system. So take the case, for example, of data access. A Windows application would call Windows. All Windows applications could call the Windows Data Access API, and we could have service providers that talk to Oracle, that talk to DB2, that talk to SQL Server, that talk to DBase files, etc. You could do this for data access. We'll do this for mail as we add mail in. We'll do this for software licensing, for For directory, in essence, it's already been done